Okay, so this is SIA Double Word Science Foundation, June 2010, non-modular paper 3. So we have two resistors are connected between X and Y as shown. Complete the table to show the total resistance between X and Y for the different switch settings. So we've got two switches, switch A and switch B. We know obviously anywhere the switch is open, the electricity cannot flow through there because it's a gap, so it has to go a different direction. So first one is switch A is open, so that one is open, and switch B is open. So the electricity can't flow this way and it can't flow down this way. So therefore it can only flow one path, which is up along here and back down. So there's only one resistor there, it's 20, so your resistance is 20. Okay. Next one, switch A is open, so it can't go here, and switch B is closed. So the electricity is now going to split and go through the top one and the bottom one. So we can just write down our formula for resistance in parallel. 1 over the total resistance equals 1 over R1 plus 1 over R2. Doesn't matter which one you call R1. R2, so you just obviously always write down your formula, show you're working out. So it's 1 over 20 plus 1 over 20, which equals to 2 over 20. So 1 over the total resistance is 2 over 20. We don't want 1 over the total resistance, we want the total resistance, so we then flip it. So we get, this becomes 20 over 2, which is equal to 10 ohms. In this question you don't really have space for working out, so what you can do is remember whenever there are two resistors in parallel, both the same, the electricity will split, and the resistance is half of one of these, so half of 20 is 10, and we've just worked it out there. But if you're more confident using the equation, do it that way. Just be aware of space and things like that. So next one, switch A is closed, and so this is A, switch B is open. So electricity can flow this way. It can't flow this way, it can flow this way and this way. Now remember, resistor is trying to stop the flow of current. The current will always try and take the easiest path. So to flow through this resistor, it's trying to stop the current, so it's not going to flow through there. Along this path there are no resistors, so it's the easiest path to go through. So in this case, when A is closed, it is just going to flow straight through. It's not going to go up this way because it's trying to stop the current. It's going to flow from X straight to Y, so our resistance is 0. Okay, last one. A is closed and B is closed, so it can flow this way, this way, this way. Again, electricity is looking for the easiest path to flow through. It's not going to flow through there or there because it's got the easiest path, but there's no resistors to try and stop it. So again, resistance is going to be 0.